for variables, you use two different types of scales of measurement. So you can use categorical scale and you can use dimensional scale. These two scales have been divided on the basis of which type of variables they use on their scale. If they use categorical data, which is also called qualitative data, then the type of scale is categorical scale. If the scale uses numerical data, which is also called quantitative data, then the type of scale is dimensional scale. Simple. There's your qualitative data and quantitative data. If qualitative data is present on a scale, then the scale of measurement is categorical scale. But if quantitative data is present on a scale, then the type of scale is dimensional scale. Okay. Under categorical scale, there are two types of scale: nominal scale and ordinal scale. Since both nominal scale and ordinal scale, they fall under categorical scale, both of them use qualitative data. However, the difference is that nominal scale uses names as qualitative variable, but ordinal scale uses qualitative variable in an order. Again, nominal scale, it simply contains names as qualitative variable and it does not show any order, so there is no order. However, in ordinal scale, the qualitative variables, they are present in an order, which you'll come to know better when I give you examples of both of them. Okay, under dimensional scale, you have two that you need to know. There's your interval scale, and then there's your ratio scale. Both interval scale and ratio scale, they use quantitative variable on an scale, and both of them together can also be called your metric scale. So overall, you can also say that the scales of measurement, they are of three types. So there's your nominal scale, which is a type of categorical scale. There's your ordinal scale, which is also a type of categorical scale. And finally, there's your metric scale, which is basically your dimensional scale. Out of all these three scales, nominal scale and ordinal scale, they use qualitative data on a scale, while metric scale uses quantitative data on a scale. Okay, and the difference between nominal scale and ordinal scale is that the type of qualitative variable or qualitative data used on a scale in nominal scale are basically names. So names are present. And there is no order, by the way. There is no order. However, in ordinal scale, qualitative variables are present in a particular order. In metric scale, basically there are measurements. As simple as that. Now, let me make the whole thing clear with the help of examples. All right. First, nominal scale. As I said, on scale, there are qualitative data. These qualitative data, however, are not present in any particular order. For example, you go to a person and ask the person his blood type as per ABO system of blood grouping. So ABO system of blood grouping. The answer would be either A, B, AB, or O. So these all are your qualitative data. A blood group, B blood group, AB blood group, O blood group. They are all your qualitative data. However, these qualitative data, they are not present in any particular order. That is, there is no order in between these data. B is better than A, AB is better than B, O is better than AB. You can't say that. So there is no particular order. Similarly, RH blood grouping. You have either RH positive or RS negative. Again, there is no particular order between the two. Anemia. You either have anemia or you don't have anemia. There is no particular order between the two answers. Type of anemia. Type of anemia. It can either be iron deficient anemia or folic acid anemia or any other type of anemia. Again, they are all qualitative data present on a scale showing no particular order. Obesity. Obesity. Yes or no. The person either has obesity or does not have obesity. Qualitative data but not present in an order. Now let me give you examples of ordinal scale where qualitative data are present on a scale. Let's say you go to a cancer patient and find out the stage of cancer. The stage of cancer, which is either stage 1, stage 2, stage 3 or stage 4. Stage 1, stage 2, stage 3, stage 4, they are qualitative data because number 1, you can't measure it. That is, you can't say how much stage 1 cancer a person has. And number 2, you can't compare it. You can't say that stage 1 cancer of person A is more than stage 1 cancer of person B. You can't compare it. So they are qualitative data. However, these qualitative data, they are present on a scale. That is 2 is more dangerous than 1. 3 is more dangerous than 2. 4 is more dangerous than 3. So there is a trend of increasing adversity. Similarly, you have grading of obesity, where obesity level is present in an order. Similarly, there's your severity of anemia. You either have anemia or you don't have anemia, but you can have various levels of severity of anemia. You might have mild anemia or moderate anemia or much severe condition of anemia. Similarly, you have hypertension classification. Hypertension classification, where it's either normotensive, pre-hypertensive, hypertensive, grade 1 hypertension, grade 2 hypertension. Qualitative data present in an order. Okay, so that was for qualitative variable, qualitative data on a scale. For metric scale, you simply have quantitative data present on a scale. Basically, data that can be measured and compared, like your weight, height, hemoglobin level, sugar level, cholesterol level, pulse rate, body mass index, temperature, age, etc. Metric scale includes interval scale and ratio scale. Both interval scale and ratio scale, they use quantitative data. But the difference is that the quantitative data present in interval scale does not show any ratio. So there is no ratio possible. However, the quantitative data in ratio scale shows ratio. So ratios are possible. Ratios are possible. Let me give you an example. So let's say you have a bucket of water that is 100 degrees Celsius and another bucket of water that is 50 degrees Celsius. At this condition, you cannot say that bucket A is twice as hot as bucket B. You can't provide a ratio in between the two temperatures. You can't say 100 degrees Celsius by 50 degrees Celsius equals to 2:1. This is not possible. So examples would be degree Celsius and degree Fahrenheit temperature. Okay. Under ratio scale, ratio of the quantitative data is possible. For example, weight of first person is 60 kg and the weight of second person is 30 kg. At this condition, you can say that the weight of second person is twice as that of weight of first person. Basically, 60 by 30 equals to 2:1. So ratio is possible. Other examples would include height, hemoglobin level, sugar level, cholesterol level, pulse rate, blood pressure, age, body mass index, and mid arm circumference. There is one extra point that you need to know to compare in between the two scales, and that is under interval scale, you don't have quantitative data, which basically you do not have any absolute zero. So there are no quantitative data with absolute zero present in interval scale. So no absolute zero. For example, degree Celsius does not have an absolute zero. Degree Fahrenheit does not have an absolute zero. For example, you have 0 degree Celsius, and below 0 degree Celsius you have minus 20 degree Celsius, minus 30 degree Celsius, and so on. So it does not have an absolute zero. However, in ratio scale, the quantitative data does have an absolute zero. So absolute zero is present. For example, you have 0 kg, and then below 0 kg you have nothing. That is why you would include Kelvin temperature here, because Kelvin temperature also has absolute zero. There is nothing below 0 Kelvin.